Okay, so let's start the recording now. Okay, we will be going through the next few worksheets. So let's start. Okay, so currently what we have done is we have actually learned how to calculate MR. We have learned how to calculate the mole of a substance. Okay, we learned how to calculate the atoms, how many atoms there is and stuff like this. So for today, what we're gonna do is we're gonna look at this concept called the molar mass. Okay, so for today, let me zoom in a little bit more. We're going to state what molar mass is, okay? And we are going to learn how to calculate the mass of a substance using molar mass, right? When given number of moles, and then also we're also going to learn how to calculate number of particles of a substance when given their mass. So we're going to look at a little bit more on the calculation part, how to interconvert, okay? How to interconvert between the different quantities. So let's go on. Okay, so let's start with the first part. What exactly is the molar mass? Okay, what exactly is the molar mass? Okay, so let me have it my pen correct in the red color. Okay, so the molar mass, okay, molar mass refers to the mass of 1 mole of a substance. Okay, so I say again, the molar mass refers to the mass of 1 mole of the substance. Okay, so it's just saying that, 1 mole of maybe copper sulfate, how heavy is 1 mole of copper sulfate? Or maybe the molar mass of another substance, what's its mass? Okay, so let me use an example. So they say calculate the molar mass of hydrogen peroxide. Okay, calculate the molar mass of hydrogen peroxide. So how to exactly do this? Okay, so to find the molar mass, actually it is the same as finding the MR. So I say the relative molecular mass is actually also to find the relative molecular mass is also the same as finding the molar mass. Okay, so how to find the MR of hydrogen peroxide? How to find the molar mass? So molar mass. Okay, so let me show you an example. The molar mass, which is the MR of H2O2. How to go about finding it? So it's the same as finding MR. So ask yourself first, how many atoms of each of the elements that you have? So in here, H2O2, you know that there's 2 hydrogen, there's 2 oxygen. Okay, there's 2 hydrogen, there's 2 oxygen. So let's go to the periodic table and let's see what is the relative atomic mass of a hydrogen, what's the relative atomic mass of oxygen. So go in, that's fine. So hydrogen is over here, the relative atomic mass is 1. Oxygen is at group 6, the relative atomic mass is 16. So I'm going to go back to my classic now. I know that the relative atomic mass of hydrogen is 1, so I substitute H as 1. The relative atomic mass of hydrogen is of oxygen is 16. Okay, sorry, ugly. Let me try again. Okay, it's 16. So this is equivalent to 2 plus 32. So that's equals to 34. So the relative molecular mass of H2O2 is 34. It is also the molar mass. Now, the interesting thing is this. I did mention in the last lesson that MR, the relative molecular mass, okay, have no units. This was what I mentioned in the previous lesson. Okay, relative molecular mass have no units. Okay, so whenever you calculate relative molecular mass, there's no units there. But when I'm finding molar mass, okay, there's actually a unit. It is gram per mole. Okay, so there is a slight difference between relative molecular mass and the molar mass, because molar mass has the units of gram per mole. Now, to make things easy for everybody, just take note. Whenever you're doing calculation, just take note of what they ask you to find. If they ask you to find molar mass, you must give gram per mole. If they ask you to find relative molecular mass, then it has no units. Okay, you'll get a bit more familiar with it later on as we go about doing more questions. Okay, now let's try to understand what exactly molar mass is. We say that molar mass refers to the mass of 1 mole of a substance. So when I calculate the molar mass of H2O2 is 34 grams per mole, this means that what? 1 mole of H2O2, okay, has a mass of 34 grams. Okay, so when I say I found the molar mass of H2O2, what it means that, okay, I've actually found how much 1 mole of the substance weigh. What is its mass? So if the molar mass of H2O2 is 34 grams per mole, it also means that 1 mole of H2O2 actually has a mass of 34 grams. Okay, 1 mole of H2O2 has a mass of 34 grams. Now, part C, they ask you calculate the mass of 2.5 mole of hydrogen peroxide. How to find the mass of 2.5 mole of hydrogen peroxide? As simple as it is, I know that 1 mole of H2O2 is equals to 34 grams. Therefore, 2.5 mole of H2O2, this will actually be equivalent to 34 multiplied by 2.5. Right? This is actually 34 multiplied by 2.5. Let me press my calculator. Right, so you're going to get 85 here. 85 grams. Okay, so this is how you're going to get here. You know that it's going to weigh 85 grams. So let's do a little bit of practice now. Okay, before we go on to question 2, okay, and find all the different things. Let's pause here. Okay, let's go all the way down to the page. Let's just draw a line like this. Okay, let's do a bit of practice. Now, on your own class kick, okay, I just want you all to try this. Find the molar mass of the following substance. I want you to find the molar mass of the following substance. So find the molar mass of H2SO4. Sorry. What's the molar mass of H2SO4? Find the molar mass of CuCl2. And the last one, do another question. Okay, find the molar mass of O2. Okay, something simpler. Okay, so take the next maybe about 3 minutes. Okay, just go and try this question out. Okay, I'm gonna pause the recording so that everyone can just take the time to go and do. So maybe give you about maybe not 3 minutes, maybe until 10:42. Okay, so you got about 2 minutes to go and do it. Okay, so let's go. Okay, so we're gonna resume now. So let's take a look. Okay, so to find the molar mass of H2SO4, how to go about finding it? Okay, it's actually just to find the relative molecular mass of H2SO4. So this is equivalent to 2H plus 1S plus 4O. You look at your periodic table, H would be, the mass of H is 1. The mass of sulfur would be 32. And the mass of oxygen would be 16. Okay, sorry, not equal here, it's plus. Okay, so this equals to 2 plus 32 plus 64. You're going to get 98 over here. Okay, so those who get it, good. Those who don't get it, please go and revisit how you go and calculate relative molecular mass. Now, instead of writing 98, because this is molar mass, I can't stop here. Okay, sorry, I just shouldn't write the thing. Because this molar mass, it has units. The units will be 98 grams per mole, which means that 1 mole of H2SO4 will be 98 grams. Okay, next one, copper chloride. So this is consisting of 1 Cu plus 2 Cl2 plus 2 Cl. This is equivalent to 1 times 64. Okay, plus 2 times 35.5. Okay, those of you not familiar about copper, okay, so copper is actually over here. Okay, over here. So you can see the relative atomic mass of copper is 64. So that's why 1 times 64 plus 2 times 35.5. So it's 64 plus 71. So I'm going to get 135. 135 gram per mole. Okay, so this is the copper chloride. Last one, the simpler one, O2 is made out of 2 oxygen. So this is equivalent to 2 times 16. So this will be 32 grams per mole. That is 1 mole of oxygen actually has a mass of 32 grams. Okay. Now, so what we have done, we have learned to calculate relative molecular mass. Okay, relative molecular mass. And actually, based on what we have done in part C, in actual fact, we have actually come up with one equation here already, one triangle. Okay, so I want you to draw this on the right-hand side here. Okay, what we know is that the mole, if I multiply by the molar mass, okay, I'm gonna get the mass. So this was actually a triangle that we've applied just now in part C. Okay, actually we have applied here, this triangle over there. Okay, so we're gonna be using this triangle quite a fair bit. Okay, so knowing how to calculate molar mass helps you to get to this. So knowing how to do molar mass gives you this part of the triangle. Okay, then knowing the relationship between mass mole and molar mass, that will actually help you to find the equation that you need to know. Okay, so let's go on to the next one. So question 2. Water can be broken down by electricity to produce hydrogen and oxygen gas. Okay, so then in an experiment, the electrolysis of water produces 4 mole of hydrogen gas and 32 grams of hydrogen and 32 grams of oxygen gas. Okay, so I know that what I have at the question. So I want you to make sure they underline these things. So what I have here is, write down mole of H2. So what is given to me, this 4 mole here is the mole of H2. Okay. What is given here, another second one over here. So let's highlight in green. 32 grams of oxygen gas. This 32 grams is actually the mass of O2. Now, so you got mole of H2, you got mass of O2. So they are different substances. Okay, please don't mix them up. Huh? Okay, so in part A, they ask you to find the mass of hydrogen gas. So what I want is the mass of H2. So you realize, okay, I got mass, I got mole. How to so what they want is mole of H2, because that's whatever that's given to you, right? You need to convert it to the mass of H2. Okay, so this is what the question wants. From the mole of H2, convert to the mass of H2. So how to convert mole into mass? So let's go back to the triangle here. If I got mole and I want mass, what you realize you need is the molar mass here. So mole times molar mass actually gives you the mass. So I'm going to take here, multiply by the molar mass. So I know this is the step I'm going to take. Okay, this is the step I'm going to take. So mole multiplied by molar mass is going to give me the mass of H2. So first thing I need to do, instead of straight away jumping the question, let's find the molar mass of H2. Okay, so molar mass of H2, actually it consists of 2H. H I know is 1. So the relative mass of H is 1. So 2 times 1, answer is 2. So once I found the molar mass, good deal already. Because to find the mass of H2, I will take the mole, multiply by the molar mass. That's what I'm doing here. And this is actually 4 multiplied by 2. I'm going to get 8 grams. Sorry, I didn't gram per mole. Forgot to write. Okay, so I know the mass of H2 will be 8 grams. So we're going to reverse the working here. So instead of pointing from mole to mass, you realize what's given to you now is the mass of O2. But what the question wants is the number of moles of oxygen gas. So I want the mole of O2. So I want to, from the mass of O2, get the mole of O2. Mass of O2 become mole of O2. So mass of O2 to mole of O2. So let's look at the question again. Look at the triangle again. How to go from mass to mole? You realize mass divide by molar mass give you the mole. So I need to divide by the molar mass. Okay, so you realize, oh no, I must find molar mass again, right? Okay, so let's start. Molar mass of O2 is equivalent to 2O, which is equals to 2 times 16, because this is a molar relative atomic mass of oxygen. So the molar mass of O2 will be 32 grams per mole. Right, 32 grams per mole. So once I found the molar mass of O2, then now it's easier already. So next step, I want to find the mole of O2. This is equivalent to taking the mass divided by the molar mass. So mass is in the question, the mass of O2 is 32. The molar mass I've calculated is 32 grams per mole, so it's 32. So therefore my answer here will be 1 mole. Okay, 1 mole. So what we have done, we have learned how to convert mass to mole and mole to mass. Okay, so which is over here. So we have calculated how we have learned how to calculate from mole to mass. We have learned how to calculate from mass to mole. And we have actually based it on this triangle over here. So those of you who are not very, like you see the triangle, you don't know how to use, right? So how exactly to interconvert? I'm going to show you another diagram here to help you a little bit. So I want to find from mole, I want to go to mass. Okay, so mole to mass is multiplied by molar mass. If I want to go the other way around, I want to from mass go to mole, I'll divide by the molar mass. So maybe some of you are more, maybe you think that this diagram, okay, this part here may be better for you. Okay, then so be it. Okay, use this diagram if you need be. So you don't need to memorize the triangle per se. You can actually have something that's highlighted in blue over here to help you to do the interconversion. Okay, so I want to highlight in mole concept, the interconversion between the different quantities are very important. I say again, the interconversions between the different quantities are important. So this is what we have done so far. Let's go on to the next slide. Okay, let's go on to the next slide. Now, nitrogen and hydrogen react to form ammonia. A typical industrial process, 3,300 tons of ammonia is produced in 1 day. Okay, calculate the relative molecular mass of ammonia. Okay, I think let's change this question a little bit. I don't want you to calculate relative molecular mass. I want you to find for me the molar mass, okay, of ammonia. So maybe take the next 1 minute, go and try now. What's the molar mass of ammonia? Okay, what's the molar mass of ammonia? Okay, so go and take 1 minute, go and try it now. Okay, I'm going to pause the recording to give you that 1 minute to go and try. Hold on, waiting jam again. Sorry, I can't play the music. It's okay. Never mind. I think you're enough the watitita tati. Okay, so take the next 1 minute, go and try it out. How to find the molar mass. Okay, good. So most of you, if you have followed the method which I've done previously, so first thing to find the molar mass, okay, you need to find out how many particles, okay, how many particles of each element that you have. So NH3 is the formula, consists of 1 N, so ammonia consists of 1 nitrogen and 3 hydrogen. If you go to your periodic table, you realize nitrogen, the relative atomic mass is 14, hydrogen relative atomic mass is 1. So going back to here, it will be 1 times 14 plus 3 times 1. So I'm going to get 17 grams per mole. Okay, so molar mass of NH3 is 17 grams per mole. Now, in part B, they ask you calculate number of moles of ammonia produced in 2 days. So what they said was there is 3,300 tons of ammonia produced in 1 day. 3,300 tons of ammonia produced in 1 day. They want you to find what's the mole of ammonia produced in 2 days. So let's do step by step. What I'm going to do first, okay, always, whenever you do the calculation, have a frame. Ask yourself what you're going to find. So first thing, you're going to need to find what is the mass of ammonia produced in 2 days. Okay, that's the first thing I need to find. Okay, so this is the first thing I need to find. Once I got the mass of ammonia in 2 days, then it makes life easier because I'm finding mole, right? So I know that in the second step, I need to find is the mole of NH3 produced in 2 days. So mass to mole, I know I need to divide by the molar mass, okay, based on whatever diagram that we have done just now. Okay. Sorry, I got one person who just came in. I need to admit the person. But my mouse is not working. Okay, wait. Okay, good. Okay, so these are the steps I'm gonna take. So let's do the first one. How to find the mass of NH3 produced in 2 days. So this is actually equivalent to 3,300 tons, okay, times 2. Because there's 3,300 tons produced in 1 day. So in 2 days, I will produce 6,600 tons. Okay. Now, the interesting thing is this. You realize your molar mass is gram per mole. I cannot use the unit tons because tons is not grams. You cannot just use tons and divide. So you need to convert the tons to gram. So they say 1 ton is 1,000 kg. 1,000 kg, you know, is 1 million grams, right? So this fella here, 6,600 tons, is actually also equivalent to 6,600 plus another. Sorry, this one I got calculation error. Can you please cancel this one? There's only supposed to be 6 zeros. Okay, I put an extra 0 there. So 1 ton is actually equals to 1 million gram. So 6,600 tons will be 6,600. Add another 6 more zeros at the back. Grams. So you need to convert to grams. Okay, so mass of NH3 in 2 days would actually be 6, then 0 grams. Okay. Now, once I found the mass of NH3 produced in 2 days, I'm gonna be doing the next step, which is step 2, to find the mole of NH3 in 2 days. I find the moles of NH3 produced in 2 days. So how to find? It's actually taking the mass divided by the molar mass. So I know it's 6,600, 1, 2, 3, 1, 2, 3, divided by 17. Okay, you're going to get a very massive number here. So I'm going to convert it to standard form. Okay, let me convert to standard form here. Okay, sorry, I don't know how to use this calculator. Oh my goodness. Sorry, Okay, so what you're gonna get is 3.88 times 10 to the power of, times 10 to the power of 8 moles. Okay, so you write it in standard form, you're gonna get this. Okay, so final answer is in 3SF. Okay? So this is the number of mole of NH3 produced in 2 days. Right? So you can see it's a massive amount, massive amount in mole. Now, next one, even more power. They ask you to find the number of ammonia molecules produced in 2 days. Wow, this one jialat already. Ammonia molecules produced in 2 days. Sure, we got calculate particles, right? Particles, molecules. Oh my goodness. What you realize is this. You know that 1 mole, okay, is equivalent to 6 times 10 to the power of 23 particles. Now I got this number of moles. I want to find how many molecules. So what do you think is the step? So what you're trying to do is from mole, I need to convert to particles, right? In this case, these particles I'm looking at is actually the molecules. So to convert from mole to particles is actually to multiply by 6 times 10 to the power 23. Okay, multiply by 6 times 10 to the power 23. So calculate the number of moles of calculate the number of ammonia molecules produced in 2 days. So I'm going to find the molecules produced in 2 days. And NH3 molecules produced in 2 days. So I'm going to take the mole, which is 3.88 times 10 to the power of 8. This is the mole. I'm going to multiply this by 6 times 10 to the power of 23. This is your Avogadro's constant. Okay, so I'm going to take this number, multiply by 6 times 10 to the power of 23. What you're going to get is a super big number, which is 2.33 times 10 to the power of 32 molecules. Okay, so this is round off to 3SF. Okay, so take this down. Now, so as you're writing down, I just want you to take note. The reason why we need mole, okay, the reason why we need mole instead of writing everything in particles like molecules, atoms, I think you will get a sensing now. Okay, can you imagine writing 2.33 times 10 to the power of 32 molecules? Okay, everything you're calculating atoms and molecules, the number is just too ridiculously big already. Okay, therefore, we don't really use molecules most of the time when we do chemical calculation. We normally will use the idea of mole. Okay, we don't use molecules, we don't use atoms, we don't use ions. Typically, when we do calculations, we use the concept of mole. Okay, that will actually make life easier for us. Okay, so I want you to now, as this part over here, as a summary. So we did in the previous page, okay, we actually have done sort of like a little summary on how to convert between mole to mass, how to convert mole to mass. On this page, a little summary, how do I convert mole to particles? Okay, so I'm just going to draw a line here. So I'm going to draw the same diagram. So mole, if I want to convert to particles, this actually multiply by 6 times 10 to the power of 23. Of course, if you want to from particles go to number of moles, is to divide by 6 times 10 to the power of 23. Okay, so this is another interconversion. So you have learned how to convert from mole to mass. You have learned how to convert from mole to particles. Okay, so actually you have picked up 2 triangles over here. Mole, particles, and this is the Avogadro's constant, which is 6 times 10 to the power of 23. Okay, 6 times 10 to the power of 23. Okay? Okay, so we have picked up 2 main triangles, 2 main interconversion. Okay, I say again, 2 triangle, 2 main interconversion. You realize the triangles involve mole. Okay, definitely is mole convert to something else or something else convert to mole. Okay, so that was what we have gone through so far here. Let's look at the next one. Okay, I need you to just get over the reading part, although it may sound very cheap, okay, but it's actually not too difficult to understand. Okay, just trying to make sense of it. So question 4 says an interhalogen compound is a molecule which contains 2 or more different halogen atoms. Okay, so it contains 2 or more different halogen atoms. The chemical equation to form an interhalogen compound, chlorotrifluoride, is as shown. Okay, so question is, why is this interhalogen compound? Because it consists of 2 different halogens. What exactly are halogens? So halogens, they are actually my group 7. Okay, sorry. They're actually my group 7 elements. Okay, so please take this down. So halogens are actually my group 7 elements. So chlorine trifluoride, ClF3, can you see it consists of 2 different group 7 elements. Chlorine is from group 7. Fluorine is also from group 7. That's why we term this as a interhalogen compound. Okay, so enough of this already. Now, they say chlorine trifluoride can be formed when 114 gram of fluorine gas. So this is the mass of fluorine gas. Now, fluorine gas is F2. So this is the mass of F2. Okay, so I got mass of F2 here that's given to me. When 114 grams of fluorine gas react with 2 mole of chlorine gas. So this guy here is the mole of chlorine gas. Chlorine gas is Cl2. Okay, so I'm given the mass of F2, I'm given the mole of Cl2. So what I want everyone to try here is, after I've given you a little bit of these hints already, can y'all go and try now step A and step B? Okay, those who are more gian, you want to try, you can go and try step C. But step C, I want to go through with you. Okay, so go and try part A, part B. Okay, those who are done a bit earlier, go and try part 3. So I'm gonna give you about maybe 2 to 3 minutes, maybe at about 11:06. Okay, 11:06, we will come back here. Okay, so I'm gonna pause the recording now. Okay, go and take the next 2 to 3 minutes to go and try this. Let's go. Okay, so let's carry on from here. So let's start. Okay, so part A asks you to calculate the mass of chlorine. Okay, mass of chlorine. So I know that what is given to me initially is the mole of chlorine. Okay, so always have the approach. Ask yourself how you're going to go about reaching to the answer. So what I am given is the mole of Cl2. What they want me to find is the mass of Cl2. So how to convert mole into mass? Well, how to convert mole into mass? You know that you have to multiply by the molar mass. Okay, multiply by the molar mass. So in this whole thing here, you know that you're given 2 mole as the mole of chlorine. You need to find molar mass of chlorine before you can find the mass of chlorine. So let's start with the simple one first. Let's do the molar mass of chlorine. Okay, so you realize knowing how to find molar mass is important. Huh? Molar mass of Cl2. This is equivalent to 2 times Cl. Sorry, 2Cl. Normally I write 2 times Cl. Huh? This is 2Cl. So this is equivalent to 2 times 35, 2 of 35.5. So this is equivalent to 71 gram per mole. Okay, so this is the molar mass of Cl2. Molar mass of Cl2. So to find the mass of Cl2 now, so mass of Cl2, this is to take the mole, multiplied by the molar mass. So I know that there's 2 moles of chlorine. I know the molar mass is 71. So therefore, the mass of chlorine reacted actually will be 142 grams. Okay, 142 grams. So please make sure you got the answer. If you don't get it, if you don't get the answer, make sure you know where your mistake is. Okay, if you need to clarify the doubt, please feel free to text me and drop me a message. Next one, part B. Calculate the number of moles of fluorine gas reacted, number of moles. So fluorine, I know I'm given the mass of fluorine. So I know I have the mass of F2. What they want me to find is the mole of F2. So from mass of F2, I want to go to the mole of F2. I'll need to divide by the molar mass of F2. Okay, be very agile, know how to interconvert between mass to mole, mole to mass. So I know, first thing, definitely, once again, I must find the molar mass of F2. So this is equivalent to 2F, which is 2 multiplied by 19. Okay, go to a periodic table and find. Then this is 38. So once I got the molar mass, life is easy now, because to find the mole of F2, I'll need to take the mass divided by the molar mass. So I know the mass is 114. I know the molar mass is 38. So this would tell me that 114 divided by 38, my answer will be 3. So this is equivalent to 3 mole. Okay, 3 mole over here. So I hope you got 142 grams. I hope you got 3 mole. Part C, calculate number of fluorine atoms involved in the reaction. So I want the number of fluorine atoms. Okay, there's a difference between molecules and atoms. So what I have here, I got the mole of F2. I want to find the molecules of F2 first. How many molecules of F2 there is? Only when I find the molecules of F2, then I can find the atoms of F in the total number of atoms of F. Okay, why? Because mole to molecules, I know, right? Moles to molecules, I know I need to multiply by 6 times 10 power 23. I think this one, interconversion, is just a step that you recognize and you know how to convert. But from molecules to atoms, this one, I need to think a bit. Okay, because why? one F2 molecule, okay, this is equivalent to how many F atoms? So think of it as this is a F2 molecule. Okay, this is equivalent to how many F atoms? I think if you go by visually, you can see down here, one F2 molecule actually consists of two F atoms. So one fluorine molecule will consist of two fluorine atoms. Hence, the next step from molecule to atom, I need to multiply by 2. So this part I have shaded in blue requires you to think a little bit like this. Ask yourself, one F2 molecule consists of how many of that particular atom? Okay, so there's 2 steps that I need to take for this particular question. Okay, so what are the 2 steps? First thing, let's find the number of molecules of F2, which then this is equivalent to the mole I know is 380. So I take the mole, multiply by Avogadro's constant. Okay, this secret number 6 times 10 to the power 23 or special number. So 3 multiplied by 6 times 10 to the power 23. You realize that it will calculated, it will become 18 times 10 to the power 23, which now I'm going to convert to we're going to make sure that it still stays in the standard form. So you can write this as the answer for the intermediate answer, or you can convert this to 1.8 times 10 to the power 24. This will be most probably, if you press a calculator, you're going to have 1.8 times 10 to the power 24 molecules. Okay. Now, as I mentioned, actually what you have done here is only this part only. So I need to find the last part. This is the answer here. This is the answer I want to reach. So last part, I want to find the number of F atoms. This will require me to take 1.8 times 10 to the power 24. This is the number of molecules. I need to multiply it by 2. Okay, multiply by 2. So once I multiply by 2, I'm going to get 3.6 times 10 to the power of 24 atoms. Okay, so as a wrap up for this worksheet, what we have done is to do this kind of conversions. Okay, I'm going to scroll down now. Okay, give you maybe 1 to 2 more minutes to just copy this down. Okay, but what we have done, actually, we have done this interconversions. Okay, so I'm going to scroll down to show you what we have actually done. Okay, so I'm going to rewrite this. So I want you to take note. So we have actually learned how to convert from mole into mass. And we know that this is actually to multiply by the molar mass. And we have learned how to convert the other way around, from mass to mole. We have actually learned how to divide by the molar mass. Okay, so this is the first interconversion that we have learned how to do it. And the triangle looks like this. Mole, molar mass, then this is mass. Okay, so this is the first thing we have applied throughout this worksheet here. Second one we have done is actually to find from mole going to the particles. Okay, how many particles there are? Which is to multiply by 6 times 10 to the power 23, which I mentioned, this guy here is called the Avogadro's constant. So for those who want to write down, this number here is known as the Avogadro's constant. Okay, you don't need to know the name, I just need to know this number, okay? And to convert it back from particles to mole, actually is to divide by 6 times 10 to the power 23. Okay, so we have actually done this. And the triangle, for those who are more familiar with triangle, is mole. This is 6 times 10 to the power 23. This is the particles, okay, number of particles. Okay, to be more precise, number of particles. So may say, hey, just now you atom, molecule, all this, how come different one? So particles can actually mean molecules. Particles can mean atoms. Particles can actually mean ions. So when we use the term particles, it's actually a more generic term, okay, where it could be atoms, molecules, or ions. You just have to be familiar with it. Okay, so let's go back to the previous page. So what we have done in this worksheet, we have actually covered what molar mass is. We have learned how to calculate the mass of a substance using molar mass when given the number of moles. So we have learned how to convert between mole and molar mass. So mole, molar mass. Sorry, we have now interconvert between the mole and the mass. Sorry, okay, interconversion. Okay, we're now to interconvert using molar mass. For step 3, can we confine number of particles when given their mass? Okay, so actually we have done this also. So we actually went from mass, we calculate the mole, then we calculate the number of particles. Okay, that was actually what we have done in the part B to part C. So you can revisit part B to part C. Okay, this is actually what we have done. So part B plus part C is actually what we have done in the third item over here. Okay, so we can revisit it. I must say that for more concept, it's like doing math. You need to really practice and get a hang of it. Okay, so this is for slide 4, slide 5, which is our worksheet 3. Okay, so I'm gonna do this one last part, okay, in the next 15 minutes. Okay, we're gonna learn how to calculate the percentage by mass of an element in a compound, how to calculate percentage by mass of an element in a compound. Okay, this is actually like a bit of proportion, percentage proportion. Then we're gonna hopefully be able to do 2 and 3 lah. I will go through, okay, what exactly empirical formula is and how we can derive the molecular formula of a compound from its empirical formula. Okay, let's do the simpler one first, how to find the percentage by mass of an element in a compound. Okay, so to determine how much of each element there are in the compound, we actually conduct analysis. Okay, we actually conduct analysis, chemists actually conduct analysis to find out the mass of each element in the compound. Okay, so we actually use mass to find out what's the amount of each element in the compound. The term that we use is percentage by mass. Okay, percentage by mass. So the following formula is used to find the percentage of an element in the compound. So we will take the number of atoms of the element in the formula multiplied by the relative atomic mass. Okay, relative atomic mass, AR, divided by the MR, which is the relative molecular mass. Okay, so I'm going to show you an example, part A now. Okay, part A. So let's find they want to ask you to find the percentage by mass of the following elements in their respective compounds. So let's find the percentage mass of Mg in MgF2. So percentage of Mg in MgF2, how to find? Okay, we're going to use the formula, number of atoms of the element in the formula. So I look at MgF2, there's only one Mg. So the number of atoms is 1. Let's find the AR of the element. So let's go to the periodic table. Magnesium is over here. The relative atomic mass is 24. So multiply by 24. Divided by the MR of the compound. So you realize at the bottom, we need to find something. We need to find MR, right? So let's draw a line here. Let's find the MR of MgF2. So realize we pause over here. We're going to find MR of MgF2. This consists of 1 Mg plus 2F. So 1 times 24 plus 2 times 19. So 1 times 24 plus 2 times 19. So this is 24 plus 38. You're gonna get 62. Okay, 62. So divided by MR of the compound. So this will be 62. Because this percentage, right, you need to multiply by 100% after that. So once you have all the correct numbers in, you can just key in the numbers into your calculator. And what you're going to get, in my case here, this is 38.7%. Right, this to 3SF. Right, so you realize all my figures always leave to 3SF. Now, there's part B and part C. I'm just going to show you part B again. So one more worked example of how to do it. Okay, so I'm going to show you once again using the formula up there. So let's find the percentage of O in CaCO3. So how many O do you see here? You know that there's 3 O, so 3 atoms of oxygen multiplied. Okay, so you can see I'm following number of atoms is 3, CaCO3, right? Multiplied by the AR of the element. So the relative atomic mass of oxygen is 16 divided by, now this one I'm also going to calculate again. So I need to find the MR of CaCO3. So what's the MR of CaCO3? This is equivalent to 1 calcium plus 1 carbon plus 3 oxygen. So this is 1 times 40 plus 1 times 12 plus 3 times 16. Okay, so this is 40 plus 12 plus 48. You realize that this is 100. So divide by 100 times 100. You realize your answer will be 48.0%. 3SF. Okay. So there is a benefit in trying to remember the relative atomic mass, but you don't need to memorize, because if you have done enough of the MR, if you keep flipping to and fro from the periodic table, you don't go and keep asking people, go and look at the periodic table yourself. Once you get familiar with it, automatically your mind will remember the number already. Okay, so I want you to take the next maybe 2 to 3 minutes, go and try part C. Okay, take the next 2 to 3 minutes, go and try part C. Okay, so I'll pause the recording again. Take the next 2 to 3 minutes, go and try part C. Okay, so let's go through this one. Okay, I hope y'all would have gotten your answer, but in case y'all don't have, okay, just double check. So we're gonna find the percentage of N in Cu bracket NO32. Now this one tricky, right? Because of that bracket 2, right? So in actual fact, Cu NO32, this guy over here, actually means that there's Cu N2O6. So there's 2 nitrogen, 6 oxygen. So this is when you really go and find out how many atoms of each element there is. So once I know this, makes it easier, because N, how many nitrogen do I have? 2 atoms of nitrogen. The relative molecular mass of the relative atomic mass of nitrogen is 14. Next, I need to find the MR of this fella. So let's go and find the MR of Cu bracket NO32. This is equivalent to 1 Cu plus 2N plus 6 oxygen. So this is 1 times 64 plus 2 times 14 plus 6 times 18. Okay, so 64 plus 28 plus 6 times 18, you're gonna get 200. Okay, can I just check everyone? Okay, you all should have 200, right? Okay, I just double check one more time, just in case. Oh no, wait. My calculator is giving me weird numbers. Okay, but should be correct, 200. So now I know that this is 200. Then I multiply by the percentage, which is 100. So it's 28 over 200 times 100. You're gonna get 14%. Okay, sorry, I'm not gonna write 14%. I'm gonna write 3SF. So 14.0%. Okay. So this, okay, this is the answer for part C over here. Okay. Any questions so far? Okay, please make sure that you drop me a text, or if there's anything you want to notify me, drop me a text. My WhatsApp app, my WhatsApp web is open, so I will see your things you want to text me. Okay, so we have actually done this percentage by mass of the element, which is important, okay, because the next 2 parts will depend on this percentage by mass already. Okay, let's go on. Woohoo. Slide 7. Okay, so hydrated salts contain water of crystallization. Okay, so when we say hydrated salts, that means the salts actually innate, not because it's dissolved in water, but the salts naturally contains what we call water of crystallization. So example will be copper sulfate. Hydrated copper sulfate actually contains 5 water within it. Hydrated iron 3 nitrate actually contains 9 water within it. Okay, so it's actually quite a cool, because of the hydration, that's why you can get all these nice colored crystals. Okay. okay, I can see one of you actually told me that it's supposed to be 188. Paiseh, my calculator didn't give me correctly. So this is 188. Thanks for notifying. So this is 188. Then my down here will be different already, my answer. So this is 28 divided by 188 times 100. So we're gonna get, oh no, why my computer looks so weird then? Okay, then I'm gonna get, sorry, this will now be 14.9%. So 14.9%. Okay, thanks for notifying on this. Oh yes, okay. So I know where the mistake is already. The relative mass of oxygen is 16. Okay, my bad, this one, my bad. Okay, so the relative mass of oxygen is 16, not 18. Okay, thanks. Okay, so take note, correction, so mass of oxygen is 16. The mass here is 188. You key in 188 here, you get 14.9 over here. Okay. Oops. Okay, so let's go back to slide 7. Okay, so hydration, water crystallization. Okay, so to find water, so there are questions they may ask you to find what's the percentage of water in the crystals. So we're gonna look at what we call percentage water in the hydrated compound. So realize the formula looks the same. Okay, so instead of atom of the particular element, okay, we're actually looking at the number of molecules of water multiplied by the amount of water. Okay, so find the percentage of mass in hydrated copper 2 sulfate. So water, copper 2 sulfate, you can see it's over here. So I'm going to write the formula. Percentage of water, okay, in CuSO4.5H2O. So how many water do you see here? There's 5 water, right? So 5 molecules of water multiplied by the mR of water. So mR of water, how to find? So this is actually equals to 2 hydrogen plus 1 oxygen. So this is 2 times 1 plus 1 times 16. I'm going to get 18 over here. So this is 5 times 18. Now, mR of the compound. Wow, this one is another big molecule over here. So we will take the side to calculate mR of CuSO4. So realize as I work, I realize I must do something else. I'll do the working on the side. So these are some of the steps you can take. So you don't have to do everything on one shot. mR of CuSO4, this will be mR of CuSO4 dot 5H2O. So let's calculate every single thing. This is equivalent to 1 Cu plus 1 S plus 4O plus 5 H2O. So this is 1 times 64 plus 1 times 32 plus 4 times 16 plus 5 times 18. Okay, so you can see the numbers are getting massive, and that's where you really need to not be afraid of it. Just really do it as per normal. Okay, so if you press a calculator, this should give you 250. Okay, this should give you 250 over here. So 64 plus 32 plus another 64 over here plus another this is 90. So you can get 250. Okay, times 250 multiplied by 100. So press your calculator. So you're going to get 36%. So this is 36.0%. Right? 36.0%. Okay, so once I've done this, now I want everyone to try part B now. Okay, take maybe the next 1 to 2 minutes. Okay, go and get used to this whole tedious calculation. Okay, go and find for me what's the percentage mass of water in hydrated iron 3 nitrate. Okay, 2 minutes, go and try it out now. Let's go. Okay, so let's do the calculation for this one now. They want to find the percentage mass of water in hydrated iron 3 nitrate. So iron 3 nitrate has this formula here. So you realize, wow, this is getting massive. Okay, so it is percentage of water in Fe bracket NO3 3.9 H2O. Okay, just double check. Yes, it is 9H2O. So there's 9 water inside there. So I'm going to use 9 multiplied by 18 because there are 9 molecules of water. Okay. What's the MR of this thing? So this is the one I need to find. So what's the MR of Fe bracket NO3 3.9H2O? So this consists of 1 Fe plus 3 nitrogen. Okay, so I times the 3 in, so 3 nitrogen plus 9 oxygen plus 9 H2O. Okay, this 3 nitrogen, 9 oxygen is actually because I take the NO3 and I'm expanded it in. So you can see this is Fe N3O9 because I multiply a 3 in dot 9 H2O. Okay, so I multiply 3 in, so it makes my life easier when I do the calculation. Okay, so this will be 1 times 56. Okay, Fe, I'll just double check. Fe is 56, right? Yes, the relative atomic mass of Fe is 56. 3 times of nitrogen, nitrogen is 14. 9 times of oxygen, 16. Plus 9 times of water, which is 18. Okay, so press your calculator to find all this. So 56 plus 3 times 14 plus 9 times 16 plus 9 times 18. You're going to get 404. Okay, 404 over here. So I'm going to write 404 here. Multiply by 100%. So this is 9 times 18 divided by 404 times 100. So your percentage would be 40.1%. Okay, 40.1% over here. Okay, 40.1%. Now, part C actually is an application of your percentage by mass. Okay, percentage mass. Now, because what you have done is you realize, you have calculated 40.1% of the particle by mass is water. So now if I know that there's 55% of hydrated iron 3 crystal, can I find the mass of water? Answer is yes. So to find the mass of water, actually what I can do is I take the percentage mass of water in Fe bracket NO3 3.9H2O multiplied by the mass of my Fe bracket NO3 3.9H2O. So you take the percentage mass multiplied by the mass. I say again, you take the percentage mass of water multiplied by the mass of the substance itself. You're going to get the answer. So it will be 40.1 over 100 because this percentage, so 40.1 divided 100 percentage times 55. You're going to get to your final answer, which will be, let me get my calculator out. This will be 22.1 grams. Okay, this will be answer 22.1 grams. Okay, so what we have done here, we have learned how to calculate the percentage mass of a substance, right? Percentage mass of a substance. Okay. Percentage mass of an element, okay, in a given substance. Or we have actually learned, and we have actually find the percentage mass of water in a hydrated crystal. Okay, so this is what we have covered thus far. Okay, I'm not going to go into empirical formula, but what I'm going to end off here is maybe a checkout question. Okay, a checkout question in terms of percentage mass. So what you find for me the percentage of okay, I want to find the percentage of Fe in Fe2 bracket SO4 3. Okay, find for me the percentage of Fe in Fe2SO4 3. Next one, I'm gonna ask you to help me with, okay, as a checkout question. Okay, it's actually maybe let me go online to find some hydrated crystals. Okay, example hydrated crystals. Oh, okay, so there's quite some cool ones. Let me go. Okay. So another one I want you to help me with is percentage of water in, okay, this cobalt, CO, cobalt, Cl2.6H2O. Find the percentage of water in cobalt chloride dot 6H2O. Okay, so these two questions will be the checkout questions. So you can take your time to go and do to just crystallize the whole thing. Okay, so let's go back to the previous page. Actually, what we have done, we haven't gone to 2 and 3. We have still at part 1 only. So we are now still calculating percentage by mass of an element. Okay, so we have done this. Okay, we have done percentage mass of water as well. Then we have actually covered the interconversion. Okay, the two diagrams over here. So please make sure you can revise it. Okay, you can go and try some questions out, some practice questions if you want to. But these two will be your main two checkout questions. Okay, so you can send me a picture of what you have done. Okay, to see whether you have done it correctly or not. Okay, so I will now stop the recording. Okay, because I got an announcement to make for all of you.